In this lesson, we're going to talk about solving trigonometric equations. So it says first, verify that each x value is a solution to this equation. So here's our equation. And I want you to notice the cosine squared here. This could also be written as this, 2 times the cosine of 4x squared minus 1 equals 0. Those are equivalent statements. So if you see the cosine squared, that's really meaning the entire thing, the cosine of 4x being squared. So I'm going to use that as my framework to plug in these x values, like for a here. Okay, so I'm going to plug in pi over 16 in for x. So I'm going to go 2 times the cosine of 4 times pi over 16 squared minus 1 equals 0. So we need to check to see if it equals 0. All right, so let's clean this up here. 4 over 1 times 16 is really pi over 4, right? And so I need to think about, okay, what is the cosine? 2 times the cosine at pi over 4, and I'm going to square it minus 1. So think about my unit circle. Pi over 4 is right here. What's the cosine there? Well, it's the square root of 2 over 2. All right. When I square that, I'm going to come over here. I'm going to have 2 times square root of 2 squared is 2. 2 squared is 4, so I square the top and the bottom. Minus 1 needs to equal 0. And here I can multiply straight across, so I'll have 4 over 4 minus 1 equals 0. And is that true? 1 minus 1 is 0. Yes, that is a true statement, so we're good. Let's do the same thing with part B. All right, so I'm going to do 2 times the cosine. I'm going to go ahead and put 4 over 1 times 3 pi over 16 squared minus 1 should equal 0. So if I reduce this, okay, it's going to be 2 times the cosine of 3 pi over 4 squared minus 1. All right, where's 3 pi over 4? Well, 3 pi over 4 is over here, and it's a negative square root of 2 over 2 for cosine. So 2 times negative square root of 2 over 2 squared minus 1. Scooch it over here. And then 2. When I square a negative, it becomes positive. Square square root, it just becomes 2 over 4. Looks familiar, doesn't it? Minus 1. That'll be 4 over 4. Minus 1 is 0. That is 1 over minus 1 is 0. So we verified that those are indeed solutions. Now, before we move forward, I just kind of want to jog your memory from some basic solving principles that we used back in algebra. When you have squared terms on one side and non-squared on another, it might be tempting to just cancel out an x, but that's not what we want to do. What we want to do is put them all on one side. So it looks like this, x squared minus 2x equals 0. And then what would we do? We would factor an x out, and then we could set each factor equal to 0 and solve from there, right? No big deal. So x would be 2. All right, that's the process we would take in a scenario like this. Look at number 2. Same idea. We want to get it all on the same side, right? Before we start solving. So this time, if I take an x out, I would have 3x minus 1. Remember, x divided by x is 1. It's not 0. All right. And then again, I would set each factor equal to 1 or equal to 0 and solve it from there. Okay. So this would be x is 0. This would end up being x is 1/3. Okay. Now let's look at this last one for a second. How does this change things? Well, we want to solve this, and I'm going to move the 1 over here. So 4x squared is going to be 1. My next step, before I take any square roots to get rid of the squared term, I need to divide both sides by 4. So I'll have x squared equals 1 over 4. Now I take the square root. All right? And remember, when you take the square root, you're getting the absolute value of what happens over here. All right? The absolute value, well, this can be the square root of 1 over the square root of 4, which is going to be 1 over 2, right? But since it's absolute value, I have to keep in mind it could be positive or negative 1 over 2. So I have more than one solution. Now, using those same principles, we're going to apply this with our trig functions. So watch what happens as we put in trig functions to find solutions, right? And our solutions will actually be angles around our unit circle. So let's solve the equation. It says find all the solutions, and I'll tell you the difference on that in a minute. Well, let's just solve for x, okay? Our first step would then be to move that 1 over. So 2 sine of x equals 1. Then I would divide both sides by 2. And I would take the sine of x is equal to positive 1/2. All right, so then I think about my unit circle. Here's my unit circle. Where's sine positive? It's positive in quadrant 1 and quadrant 2. Where is it 1/2? Okay, it's 1/2 right here at pi over 6 and at 5 pi over 6, right? So x would be equal to pi over 6, and x is equal to 5 pi over 6. Now, since it says all solutions, I would be done if it just meant within 1 revolution, within 2 pi. But since it says all revolutions, I have to consider this. Okay, there's pi over 6. If I add 2 pi, that would be a coterminal angle, right? So that would be 13 pi over 6. Add another 12 pi over 6. I would get 25 pi over 6. I could keep doing revolutions, right? Full circle revolutions. When I do that, the way to notate that, instead of having list out eternal possibilities, I would just say plus 2n pi. So 2 pi is a full revolution. N just says I can keep making circles all the way around. Same would happen with the 5 pi over 6 angle. If I keep adding a full revolution, I would end up in this location, and my sign would still be positive 1/2. So instead of just saying, listing all of them out, I notate it 2 pi n. All right? So what does that 2 pi n do? Well, this accounts for all the coterminals out there. And you're going to want to, excuse me, do this anytime it says all solutions, all right? Now there's some shortcuts, and I'll show you as they come along, but this one, that's your answer. Let's look at number 2. Sine of x plus the square root of 2 minus the sine of x. All right, so let's start by getting everything on one side of the equal sign. All right, so when I do that, I'm going to have the sine of x plus the sine of x plus the square root of 2 equals 0. Now, I'm going to combine these, so I'll have 2 sine of x. I'm going to move that square root of 2 over here, so it's negative square root of 2, divide by 2. So now it's where's the sine of x? The negative square root of 2 over 2. All right, so let's think about our unit circle. Sine is negative down here in quadrant 3 and quadrant 4. Where's the sine square root of 2 over 2? Well, that would be at the pi over 4 angle. So in quadrant 3, that would be 5 pi over 4, and that would be 7 pi over 4, right? So it's the same kind of logic. X can equal 5 pi over 4. X will equal 7 pi over 4. And that would be my answer if it said within 1 revolution. But since it says all answers, I need to add in the 2 in pi, because every possible revolution, there's going to be a coterminal angle. Look at number 3. 3 tangent squared x minus 1. So let's solve by isolating the trig function. So I'm going to 3 tangent squared x equals 1. Divide both sides by 3. Then I have the tangent squared x is 1/3. Now I've isolated the squared term here. That's what I wanted to do. And then I take the square root of both sides. So now I know that's the absolute value of tangent x is equal to, let's break this up, square root of 1 over the square root of 3. Square root of 1 is 1, over the square root of 3 is square root of 3. All right? Now, I should theoretically rationalize this, right? So I need to multiply the top and the bottom by the square root of 3, which will ultimately give me square root of 3 over 3. Maybe you see that from the get-go, that's fine. So now I'm saying the absolute value of tangent x is square root of 3 over 3. So to get rid of the absolute value, I put the plus and minus, right? So that's positive square root of 3 over 3 and negative square root of 3 over 3. All right, so if you remember the trick I told you, what angles have a tangent of square root of 3 over 3? The memory trick that I use is there's 2 3's here, so they add up to 6. So at my pi over 6 angles, the tangent is square root of 3 over 3. I can walk you through how I got there if you'd like. For instance, I'll just do it with this first angle at pi over 6. Right here I know that the cosine is square root of 3 over 2 and the sine is 1/2, right? Well, tangent is y over x. So if I take 1/2 and divide it by the square root of 3 over 3, or square root of 3 over 2, I ultimately multiply by the reciprocal. That gives me 1 over the square root of 3, and then when I rationalize it, it becomes the square root of 3 over 3. This same pattern will occur over at pi over 6, at 5 pi over 6, down here at 7 pi over 6, and at 11 pi over 6. So the way I remember it is the 6 is the 3's added together. That's how I remember it. The pi over 6 angles have a tangent of square root of 3 over 3. So when I start to write this down, let's look at this. So x will equal pi over 6, and I'm going to do pi over 6, and then I'm going to do 5 pi over 6. Let me show you why. When I do pi over 6, if I do pi over 6 and I add a pi, don't I end up here at 7 pi over 6? Same thing with 5 pi over 6. If I go 5 pi over 6 and I add a pi, I end up over here, right, at 11 pi over 6. So instead of adding 2 pi revolutions, if I just add a half a revolution, a pi, I end up at another angle with the same tangent value. So to reflect all the possibilities, I'm going to take pi over 6 and I'm going to add in pi. So I only have to add a pi before I get to another angle with that same tangent value. So I need to list them separately because 5 pi over 6 is at in a different quadrant than pi over 6, and you need to add a pi to end up in quadrant 4. So hopefully that makes a little bit of sense. If not, we'll rehash that when we get to class, so let me know if you need help with that. All right? Jumping over to number 4, cotangent. All right, cotangent. So I need to solve this. I'm going to move my 1 over. So I'm saying the cotangent of x is equal to -1. All right, so cotangent is just the reciprocal of tangent, right? For it to be -1, that means the tangent would be -1. So cotangent is x over y, and it's negative. Where are the x and the y values different? Well, that would be over here in quadrant 2 and in quadrant 4. And where's the tangent 1? Let's think about that. Well, that's at the pi over 4 angle. So in quadrant 2, that would be 3 pi over 4. And in quadrant 4, that would be 7 pi over 4. My mistake, 7 pi over 4. So where is the cotangent -1? Well, I can say x is equal to 3 pi over 4, and x is equal to 7 pi over 4. And then I can add every coterminal angle after that, so it would be 2 in pi, right? So this is the same thing I could do on the previous, but I'm just showing you the shortcut here. Do you see that these are just 1 pi distance away from each other? They're catty-corner, right? So I can rewrite this. This is not incorrect. What I have right here is not incorrect, but you can simplify your answer and say x is equal to 3 pi over 4 plus n pi. And that accounts for the 7 pi over 4 because it's going to, every pi, it's going to say the cotangent is -1, and sure enough, it is. Once you start at 3 pi over 4 and you just go pi distance, that cotangent will be -1. So either way is a correct answer. All right, let's try these on the back. Now these say to solve on the regular unit circle. Notice it says to 2 pi, so don't include 2 pi, but only use angles on the given unit circle. That's what this is telling us in this indication. All right, solving wise, it's the same. So I can, this one's already factored for me, so I can just do cosine x is 0. X is 0, and then I can say cosine x -1 is 0. So this one has one more step to it, so cosine is 1. So then I think about my unit circle. Where is the cosine 0? Well, that happens 2 places, right? Where x is pi over 2 and at 3 pi over 2. Where is the cosine +1? Well, that only happens at 0. So I would have another solution here where x is 0. So I have 2 sets of solutions. Number 6. All right, again, don't be tempted to cross out a sign on both sides. We want to move this over and do greatest common factor. So when I factor in a sign out, I will have a sign left minus 2. All right, then I set each part equal to 0 like we did before. One more step here, sine x equals 2. Okay, so then think about our unit circle. Where is the sign 0? Where's the y value 0? Well, at 0 and at pi. So this would give me 0 and pi. Then look at this. Where is the sign 2? Well, the highest value for sign is a 1 right up here, isn't it? It doesn't go to 2. So this would be an empty set. This part of it does not have a solution. So my only answers really are 0 and pi. Moving on. Let's try this one. So let's move our tangent over. And let's look at what can we factor out. We can take a tangent out of this, right? That would leave me 3 tangent squared x minus 1. So then it's, where's the tangent of x? 0, not 0. And then where is 3 tangent squared x minus 1 equal to 0? All right, I'm going to keep solving over here for now. 3 tangent squared x equals 1. Divide by 3. Tangent squared x is equal to 1 over 3. Then I take the square root, right? When I take the square root of this, I'm going to find out that the tangent of x is going to be, remember this is going to be 1 over the square root of 3. When I rationalize that, it becomes square root of 3 over 3. And because I took the square root, I have to put plus or minus. So I'm thinking about my unit circle. Where is the tangent 0? Tangent is y over x. So where is the y 0? Well, that happens at 0 and that happens over at pi, right? So 0 and pi. And then where is the tangent value, positive or negative, square root of 3 over 3? So remember my little trick, there's 2 3's, they add to 6. That tells me it's the pi over 6 angles. And I'm going to list every one of them because it's the positive and the negative. So I'm going to do pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. All 4 pi over 6 angles. Last one. When you try this one on your own, we'll check it when you get to class and see how you did with it. All right? It throws a secant in there, but I think you can handle this. If not, we'll address that when we get to class. All right, good luck. We'll see you then.